But at the edge of the universe, there is a place no eye has ever seen. We picture it as a wall in the dark, a final border with something waiting on the far side. It is none of those things. It is not the end of the universe, and it is not empty. It is not even very far away. It moves when you move. It keeps you at its center, and you could travel toward it for a lifetime and never arrive. It is not a thing out there. It is a horizon you carry. What we call the edge is something quieter and far harder to escape. And what lies past it is not a monster at the gate, but a kind of distance that can reach in and take everything away. Picture yourself standing in the middle of a thick sea of fog at night, holding a single lamp. The light reaches out a certain distance in every direction, and then it fades. Around you, there is a circle you can see, and beyond that circle, gray nothing. You could walk for hours toward the edge of that circle and never arrive. The fog simply opens ahead of you and closes behind you, and the circle travels with you, always keeping you at its center. That circle is the edge of the universe, not a wall, the place where your sight runs out. What we actually see when we look up is light. Light is fast, but it is not instant. It takes time to cross a room, and far more time to cross the space between stars. So when we look out as far as we possibly can, we are only seeing as far as light has had the time to travel toward us since the universe began. About 13.8 billion years of travel. Anything farther than that has light still on its way. It has not arrived. It may never arrive. Scientists have a careful name for the part we can see. They call it the observable universe. And that word observable is doing quiet, important work. It does not mean the whole universe. It means the part whose light has reached us. The rest is still out there in the fog. We simply have no way to look at it yet. So when you hear the edge described as a thing, a barrier, a final wall with a far side, hold the word at arm's length. We have not found a wall. We have found a distance past which we cannot yet see. That is a smaller claim and a stranger one, and we should be honest that it is all we have. And that 13.8 billion years is not a guess. We know it from the faint afterglow of the early universe, a glow measured to astonishing precision by satellites built for exactly this. WMAP, launched by NASA in 2001. Planck, flown by the European Space Agency through the 2000s. From that glow, we can also draw the size of what we see. The observable universe is roughly 93 billion light-years across. That is the diameter, end to end, about 46 billion in every direction from where you sit. Hold that number lightly. It describes the circle of fog. It does not describe the world beyond it. So the thing we have always called the edge was never the end of anything. It is the limit of our looking, which raises a quieter, stranger question. If the edge is just the rim of what you can see, then where exactly are you standing? Because if that rim shifts with every step you take, someone has to be at the center of it. Here is something that sounds like arrogance and turns out to be physics. You are at the center of the observable universe, not near it, at it. The light arriving at your eyes comes from the same distance in every direction, so the circle of what you can see is a sphere, and you are in the middle of it. But you are not special. That is the gentle part. Everyone is. Every person who has ever lived has stood at the exact center of their own circle of sky. And so does every creature on every world we will never meet. Billions of centers, all at once, none of them wrong. A creature on a planet in a distant galaxy is also at the center of its own observable sphere, looking out at its own circle of fog, seeing edges in every direction that are different from yours. Move to your left, and your observable universe moves with you. Every point in space sits at the heart of its own view. There is no single center that the rest of us are arranged around. If that feels impossible, picture an ant walking on the surface of a beach ball. The ant crawls and crawls looking for the center of the surface. The one special spot. It never finds one. On the surface of a sphere, every point is exactly like every other. Wherever the ant stands, the surface curves away evenly in all directions, and it can tell itself with perfect honesty that it is in the middle. The universe is like that. The center is everywhere. And so, it turns out, is the edge. This is the calm before the strange part. We have talked about what we see and where we stand. But there is a question. People are almost embarrassed to ask out loud. How do we know any of this is real? That any of these numbers are not just made up? If you're impressed by them, don't stop at just hitting like tap hype too. It only takes a few seconds, but it helps this video reach many more people. How we know and why the edge is not dark? It is a fair question, and the answer is one of the most beautiful things our species has ever worked out. Start with the strangest tool we have. A telescope is a time machine. Because light takes time to arrive, every time you look at something far away, you are looking into the past. The sun you see is 8 minutes old. The light from the nearest large galaxy left it before our species existed. Look far enough, and you are not seeing how the universe is. You are seeing how it was. The second clue hides in the color of that light. As space stretches, and we will come to why it stretches, it pulls the light traveling across it into longer waves, sliding it toward the red end of the spectrum. We call this redshift. So the color of a galaxy quietly tells us how far its light has traveled and how long it has been on the way. This is not a story. It is measured galaxy by galaxy. In 2025, the James Webb Space Telescope found the current record holder, a faint smudge of a galaxy named MOM-Z14, confirmed by its spectrum. The result was published in the Open Journal of Astrophysics in 2026 by a team led by Rohan Naidu. Its light is stretched more than 14-fold. It set out toward us only about 280 million years after the universe began, and has been falling toward your eyes for more than 13.5 billion years. That stretch is not decoration. It is the expansion of space, written into a single beam of light. Now the part that turns the whole picture inside out. We imagine the edge as black, empty, dark. It is not. The farthest thing we can see is not darkness, but a wall of light. The oldest light there is, released about 379,000 years after the beginning, when the young universe first cooled enough to become clear. It surrounds us in every direction, a faint glow we call the cosmic microwave background. We see the edge as dark only because that light has been stretched so far down into microwaves, out of anything our eyes can catch. Think of ripples spreading across a still pond. Your eye catches the first few rings near the splash. A sensitive enough instrument can trace them all the way to the far bank. The wall of light was always there. WMAP and Planck mapped it across the whole sky and measured its temperature, about 2.725 degrees above absolute zero, the same in every direction. And that glow carries one more shock. The beginning did not happen at a point somewhere out there, a single spark you could fly back to. It happened everywhere at once. In that distant galaxy, in the space between, and in the exact chair you are sitting in right now. It was all of space, everywhere, very hot and pressed close together. The wall of light is simply that moment, filling the whole sky, seen from inside. Wherever you are watching from tonight, a city, a quiet room, a phone glowing in the dark. That exact spot is the center of everything you will ever be able to see. So I'm curious, where is your center right now? We have worked out how to measure it all. Now comes the harder part. The reason that even with all of eternity, we will never reach it. Why we can never reach the edge, even given forever. To see why, you have to drop one stubborn picture. Galaxies as objects flying outward through empty space, like debris from a blast. That is not what is happening. Space itself is stretching, and the galaxies are mostly sitting still inside it, carried apart as the space between them grows. Picture a balloon with dots drawn on its surface, slowly being inflated. No dot is moving across the rubber. Yet every dot drifts away from every other dot, because the rubber between them is expanding. Or picture a loaf of raisin bread rising in the oven. Each raisin stays put in the dough, but the dough swells, and every raisin ends up farther from all the rest. What is really happening is the dough itself, space, getting bigger everywhere at once. The galaxies are the raisins going nowhere, drifting apart anyway. This finally answers the question people ask more than any other. What is the universe expanding into? Nothing. It is not growing outward into some surrounding room. There is no outside for it to spill into. The distances inside it are simply getting larger. That is a hard idea, and you are allowed to sit with it. The expansion has no edge to push against because the expansion is the space itself. And here is the consequence. The farther a region sits from us, the more space lies between us and it. And so the faster that space stretches until, past a certain distance, the space in between is growing faster than light can cross it. People sometimes say the universe expands faster than light, and that is true. But said plainly, it sounds like a broken law. It is not. Nothing is moving through space faster than light. It is the space itself growing, and space is under no such limit. The honest way to say it is gentler and worse. From those far regions, light sets out toward us and simply never arrives. The road grows faster than the traveler can walk it. We did not guess this. The rate of the stretching is measured from the redshift of exploding stars called Type 1a supernovae, which all detonate at nearly the same true brightness and so serve as standard candles, mileposts laid across the dark. And the supernovae and the ancient glow agree, which leaves us with a quiet, devastating fact. There is a horizon we can see out to, the oldest light, about 46 billion light-years away. Astronomers call it the particle horizon, and there is a closer one around 16 billion light-years out, beyond which nothing we do now can ever reach. Not a ship, not a signal, not a single photon we send tonight. That nearer line is the cosmic event horizon. These are estimates from our best model of the universe, but the gap between them is real, and it means this. There are galaxies hanging in your sky right now, galaxies you can point to, whose light is arriving this instant. And we can never travel to them or send a message to them, no matter what we build, no matter how long we wait. The horizon we can touch is closer than the horizon we can see. We are not walled in by a wall. We are walled in by time and by the widening of the dark. A story this strange struggles to cross the distance on its own. If it reached you tonight, a quick hype helps it reach one more person looking up at the same sky. And all of that, every galaxy we can see and every one we have already lost, is only the part we can see. The real universe is larger, possibly larger than any number can hold. Step back and breathe, because this part is closer to awe than to fear. Everything we have described, the 46 billion light years, the wall of light, the galaxies beyond reach, all of it is the observable universe. The bubble of fog. The whole universe is bigger, and the truth is we cannot say how much bigger. It may be infinite. We can only test which way it leans. If space is perfectly flat, as our measurements suggest it very nearly is, the universe goes on without end. If it is gently curved, then it could close back on itself like the surface of an unimaginably large sphere. Travel far enough in a straight line, perhaps 18 times the distance to our particle horizon, and you would arrive back where you started. We do not know which. That sentence is not a failure. It is the honest edge of what we know. What we can do is climb the ladder of scale, one rung at a time, and let it work on you slowly. Our galaxy sits in a small cluster of galaxies. That cluster is a suburb of a vast collection called Laniakea. About 100,000 galaxies streaming together across some 520 million light-years. First mapped by Brent Tully and colleagues in 2014. Laniakea is itself a speck against the largest patterns we have traced. Faint threads of galaxies stretching billions of light-years. And out at that scale, the universe has started handing us things it should not be able to. In 2024, the astronomer Alexia Lopez found a ring of galaxies about 1.3 billion light-years across. A structure so large, it strains the basic assumption that, on the biggest scales, the universe should look smooth and even everywhere. By the rules we wrote, it should not exist. It does. We are still deciding what that means. All of this grew from something almost too small to picture. In the universe's first moment, in far less than the blink of an eye, a patch smaller than a single atom is thought to have stretched to the size of a galaxy. The fog you stand in began smaller than a grain of dust. Hold on to that thought, because something from that first instant may still be reaching for us. There is something beyond everything we will ever see, and it appears to be pulling us toward it. Something beyond the edge is pulling us, and we may never know what. For decades, astronomers have noticed that our galaxy and a great many others are not just drifting apart with the expansion. They are also being pulled together in one direction, as if something enormous lay off in that part of the sky, calling us. The nearest suspect has a fitting name, the Great Attractor. A concentration of mass toward the constellations Centaurus and Norma, half hidden behind the bright band of our own Milky Way. But the pull may not stop at anything we can see. And that is where it stops feeling like astronomy and starts feeling like something older. Here is the loophole that makes it frightening. Something now beyond our horizon, beyond the fog, in the part of the universe whose light can never reach us, could still be tugging at us with gravity. It would only need to have touched our region in that first instant, before inflation stretched everything apart and then been carried out of sight forever. A hand that let go of us before the room went dark and is still pulling. We would feel it. We could never look at it. The hard numbers are genuinely strange. A 2023 survey called Cosmic Flows 4, led by Richard Watkins and Brent Tully, measured the galaxies within about 1 billion light-years of us. They are all drifting the same way, at roughly 419 kilometers per second, close to 4 times faster than our standard model predicts. That is a mismatch far beyond the level scientists treat as a fluke. A real, large-scale flow that current physics cannot fully explain. We are not only being pulled either. In 2017, a team led by Yehuda Hoffman found that our local group is also being pushed. Shoved away from a vast and unusually empty region they named the dipole repeller. Pulled by what gathers, pushed by what is missing, our galaxy moves at around 631 kilometers per second against the background of creation, and we did not choose the direction. How could we possibly know this? By reading the faint imprint these motions leave on that ancient wall of light, the cosmic microwave background, and by patiently cataloging the distances to thousands of galaxies. Which is also why honesty matters here, because the most famous version of this idea is still under fire. The original claim, called dark flow, proposed by Alexander Kishlinsky around 2008. About 1,000 galaxy clusters streaming at hundreds of kilometers per second toward a single patch of sky, has not held up cleanly. When Planck scanned more than 1,000 clusters, it found nothing of the kind. If such a flow exists at all, the data say it must be slower than about 254 kilometers per second. Kashalinsky's group still defends it by their own methods. As of 2026, it is not settled. We are looking at the limit of what we can currently prove, and we should not pretend otherwise. And yet, even at its quietest, the picture holds its weight. Something is moving us. We can feel the current. We cannot see the shore, but this is not the most frightening thing the sky has to offer. The most frightening thing is what the sky is slowly, silently doing to itself. Run the expansion forward, far into the future, and the loneliness becomes the whole story. Space keeps stretching, and one by one the distant galaxies are carried beyond that closer horizon, past the point where their light can ever reach a telescope again. They do not explode or vanish. They simply recede until the road between us grows faster than any light can walk it, and then they are gone, quietly, forever. The strangest part is what we are looking at even now. The light from the most distant galaxies is, in a sense, a ghost. A picture of something that has already drifted beyond our reach for good, still glowing on its way to us long after the thing itself has left. The night sky is, in part, a museum of the departed. Give it long enough, 100 billion years and more, and a future astronomer on some world in what remains of our galaxy will look up and see only our own merged neighborhood of stars. Empty black in every direction, nothing in their sky to suggest the rest of the universe ever existed at all. They could do the math perfectly and never guess the truth. We do not even agree yet on how fast the dark is growing. Measure the expansion using nearby exploding stars with the James Webb Telescope and stars called Cepheids, and you get about 73. Measure it from the ancient wall of light, and you get about 67. The two refuse to meet, a gap of nearly 9% that no one has closed. We call it the Hubble tension, and as of 2025 it remains open. We are arguing about the speed of our own undoing. So here is what is left. We are observers inside a bubble of light, in a sea of fog, at the one stretch of cosmic time when the rest of it is still visible. We happen to wake up early enough to see the other galaxies before the night swallows them. A creature born late enough will never know they were there. That is not a small and sad thing. It might be the largest piece of luck there is, because the edge was never a wall. It was only the rim of your own sight, a circle of lamplight in the fog, traveling with you wherever you stand. And maybe the most frightening thing was never the void out past it, the monster we imagined waiting on the other side. Maybe it is simply this, that there is more than we will ever see, that some of it is already calling and already gone, and that we were given one brief, lit moment in the middle of it to look up at all. What lies past that final horizon? The part that can never, by any instrument or any patience, be observed, is where this story goes next.